Hello, welcome to another episode of Power Pulse. I am joined today by Dr. Navid Madizadeh and Dr. Arturos Jordanidis. Thanks so much for coming in. Before we start talking about Econiq or Hitachi Energy's eco-efficient portfolio, I wanted to ask you, Arturos, if you've been to any cool gigs recently. I know you're very much into your live music.
Yes, nowadays I try to follow my kids and learn what is new coming. For example,
Go on.
Lana Del Rey.
Okay. Did you go to see Lana Del Rey then?
I brought my daughter to it.
Oh, okay. Fun?
Fun, particularly for her, but for me, lots of learning.
How about you, Navid? Are you a Lana Del Rey fan or a music fan at all?
Yeah. I'm a music fan, but I'm mostly the classic rock, and the young people, the young generation doesn't understand me.
You're not so old.
The only problem of the young generation is that I don't belong to it anymore.
Oh, okay. That's a bit defeatist. You're not old at all. Right. We're here today to talk about Hitachi Energy's eco-efficient portfolio. So I was going to ask you, Arturos, if you could give us a little introduction about Econiq, what it is, what it stands for. Could you take us through the history of this portfolio?
Good, Barbara. I think looking back is a good point before we start looking forward. And particularly for this kind of topic, when so much is changing today, I think it's worth to look a bit back as well. And if you look on the SF6 replacement, and Econiq is SF6 replacement, if you look back into 90s, you will find open publications coming from our company. At that time was ABB, where our researchers, scientists, they were looking into alternatives for SF6. And interestingly, the conclusions that you find in that publications, they actually valid also today. And they state that SF6 is a pretty good technical gas, and to go to something different, one has to check where is the optimum point, but technically SF6 will be the good choice for switchgear. And that is the work that was done already in 90s, so pretty long ago. If we look what happened afterward, and we go to the beginning of 2000, and this I remember pretty well because this is when I started in the company and I was part of the project that was looking into this. At that time, knowing that SF6 is so good, we start thinking, what is the best that we could do nevertheless? Slightly worse than SF6, but what can come next? And we did again a research project to understand other gases and to get the best out of what is possible to make the new design rules, etc. The outcome of that work was not only the report or lab test. It was very interesting that in 2010, together with our customer Vattenfall, this work resulted in a pilot installation in Sweden.
Right.
2010, so quite a while ago. And that was a live tank breaker, which was completely free of SF6 and was functioning for a few years, for many years, until it was decommissioned. It was fully type tested and installed and doing its work. What is interesting also that this product was built by exactly the same factory in Sweden, what we have now, that is now offering a range of Econiq products. And guess what? This is also the factory that will have also things to say in the coming SIGRE event.
Oh, wow.
What I want to stress, what we see today in Econiq, you mentioned our roadmap, and probably everyone can judge that it's very ambitious, it's going well, and it's pretty compact time-wise. It is to a very good extent based also on the history of the things that I mentioned. They were started in 90s. People were gaining the knowledge, defining the technology, design rules, and that enables us now to go in a very compact, structured, and very well predicted way with our Econiq roadmap.
Okay. So Navid, before we go into the claim that Econiq is the most eco-efficient portfolio around, can you tell us a little bit more about the equipment and what this Econiq consists of?
Yes, but let me go one step back. In addition, what Arturos mentioned, the SF6 is the perfect gas for our high voltage equipment. And there are three reasons for that. The first, the technology around the SF6, they are reliable, and reliability is very important for our sector. The second one, the technology, they are scalable. You can go for the very low voltage to very high voltage, to the 1,200 kilovolt. And the third one, the product based on SF6, they are compact. And the compactness is also very important. I will come to this when I explain why we claim that our portfolio is most eco-efficient portfolio. Our Econiq portfolio, we are replacing SF6, but we keep on maintaining these three beautiful characters of SF6, and this is important to underline. Which product they consist? We have in our portfolio not only the different voltage level, we have also different product for different application. For example, where the place is limited, we offer the gas-insulated switchgear. Where we do not have the limitation in the space, we have the so-called lifetime breaker.
So gas-insulated switchgear, that's compact?
Yes.
Okay.
And now answering your question, the Econiq portfolio, they have the same reliability as a conventional, but it is proven to deliver exceptional performance. And this performance we measure with a life cycle assessment.
Okay.
And a life cycle assessment, we call it cradle to grave. It has give a holistic view of the impact of the product on environment. This is not only the CO2 emission. There are a lot of other parameters that, like land use, water use, and other things. But let's focus on the CO2 emission. The life cycle as a measurement, they start with the raw material, right? And then starting how you transport it to the factory, how you build the product, and then you transport it to the site, and then the product, for example, if we talk about gas-insulated switchgear, 40 years in operation, and then in the end, you have a disposal or recycling. The life cycle assessment measure all these steps, CO2 step, and give you the total overview of the CO2 emission. And it is important also to mention every step of the life cycle assessment is important. It's important to consider all these steps. If you optimize one step, maybe you make the other step worse, right? This is so important to mention that once we go away from SF6, it is the most important parameter in the LCA analysis is the material. But based on our gas mixture that we use, we can keep this compactness as mentioned before that SF6 product is compact. We keep this compactness. It means this is less material. In the end, we have the better CO2 footprint.
Right. And this equipment is reliable?
Yes.
Okay. And how do you prove that?
We maintain the same technology as we have been using the 40 years for SF6. And this is proven to be reliable. Okay. We optimized the design for the new gas mixture, which replaces SF6. But the same concept and same technology as SF6 is used also for the Econiq portfolio, which we know that they are reliable.
Okay.
And by the way, now it's not only the history and it's not only the theoretical point on the reliability. No, we got recently a message from one of our first customers about installation in the US about 420 kilovolt installation when our circuit breaker, Econiq circuit breaker, was called to act because there was a storm in the area and there was a fault that was distributing in the network, and the circuit breaker has triggered Barbara and cleared this fault and reconnected the circuit such that many thousands of our customers or households and industry, they did not even notice any power shortage.
Oh, that's amazing.
The Econiq breaker was already in action for such a demanding rating, and it has proven to reliably
absolutely reliable. There we go. Thank you. That's a great story. Thank you for sharing. So Arturos, we're talking about new products and new technologies. How do customers decide which ones to go for?
It's not always very trivial, I assume, for our customers to decide what is the appropriate product for the specific application, because there are very many parameters that are important. To give an example, the size. If we are putting a gas-insulated switchgear in an existing building, obviously we don't want to rebuild the whole house because to fit into switchgear. Therefore, size is an important parameter. The same goes with the weight. when our customers install a switchgear on a platform, obviously the weight is a very big value for them. Therefore, they would select the option of technology that brings lower weight. Life cycle assessment, ecological footprint, definitely today is one of the most important ones. When one calculates the life cycle assessment, then one sees which product is the most economical. Serviceability. When you get a new technology, you don't want to start everything new. You want to reuse the experience and the people that have this experience from other technology. We take the gas insulated switchgear, gas insulated generally equipment. You would like to have similar practices. And I think all this multi-parameter optimization needs to be done by the customer before they select the technology. And we, as a supplier of the technology or developer of the technology, we try to do actually the same, that we take into account what are the customer needs, what they are interested in, and then we come with the solution. Econic portfolio is a good example of such thinking that we do internally in Hitachi Energy to be able to help the customers to have less contradictions when they need to select the technology for the future.
Maybe in addition of technical performance, we maintain the same technical performance as SFC, and this is important too.
Exactly.
So technical performance and compactness, right?
Yeah.
Okay, so Navid, if we look at the need for the equipment to stay compact, for you to do that, you take the SF6 out and you replace it with 3.5% of an F-gas, so C4FN. When I hear F-gas, I mean, the reputation of F-gas is not great, right? So can you tell me a little bit about the C4FN?
We use this very small percentage of the F-gas, the C4 pronitrile, to keep the compactness of the equipment. You need that. This is the physics. If you don't use it, you need to increase the insulating distance. Right. It means to make the devices bigger. To make the devices bigger, you need more material. And we talk about the LCA. It means that it has impact on your CO2 footprint. So, but C4FN in the mixture that we use, it is a non-toxic. Mm-hmm. And if escape from the equipment, will distribute it equally in atmosphere and will decompose in the substances around 30 years. You can find it in nature. Mm-hmm. So if you compare it with SF6 has atmospheric lifetime is more than 1,000 years. You see that the C4 nitrile, the environmental parameters, they are really good compared to SF6, and there is no concern on the health and safety and then environmental impact.
Right.
When listening to Navid, also the importance of the 3.5% of the C4, it just also in the past as well, it has happened when one of the parameter was optimal and the other ones were not following it, and then the technology was replaced by something else. What crossed my mind, there has been times before SF6 when air blast technology was the technology for switchgear. What does it mean? It means that there is a compressed, very high pressure air in a vessel with very thick vessel to keep this pressure, compressor working to be able to maintain it. And when there is a fault in the network, this air was released and was blowing the arc, which is typically something that switches from on and off the network. So basically, one parameter of the system as a environmental friendliness was quite okay because the medium was air, which is not harming the earth. However, there are quite some deficiencies of the technology, intrinsic ones, because the performance of air is not so good, insulating-wise and interrupting-wise. At that time, something that is done today with just one pole of circuit breaker, so one piece, one pillar, at that time you need like a Christmas tree of maybe 6 to 8 interrupting chambers working with air. And air was blowing through it. And when you now look back and you look the size that you need, it very many times larger, you also look the material that was used to create such a breaker, you will see that was not an optimal solution. And that is the reason why it was gone. And today new installations don't come with it. It was tuned to the one medium that was good for the environmental aspects, but all the other ones were compromised. And that's why the next technologies that came, it moved this
Right.
out.
So this air that you mentioned, and it's a question that I wanted to ask you. So I've read a little bit about clean air for high voltage. Is it the air that we're breathing right now? What's clean air?
Clean air is it's a good term for good marketing reasons.
So it's a marketing term.
Yeah,
Okay.
it's not a technical one, and in marketing terms is used and successfully used. There are filters at home that are called clean air because they clean air at home. There are also sprays neutralizing the smells in different places that are also called justified clean air. But if we speak of switchgear, and if we are go a bit deeper, then we should probably talk rather technical air or dry air, which is used in a switchgear. Now, if we want to breathe it or not, I mean, I would personally not recommend it, and I would not do it. I would not do it because when we make high pressure air in a vessel, it goes through compression. You have there oils, greases, and of course molecules from all this end up in air. So I don't think that we need to breathe this air. Even more like that when it's done its work and used in a switchgear. I mentioned the arc. Arc is always there in high voltage switchgear. So when the arc burns, it's a very thousands of Celsius plasma.
Yeah.
Therefore, everything which is around it starts melting and vaporizing. And again, these particles, be that from the plastic material, be that even from the metal that are in contact with the plasma, they start evaporating and end up in air. So after the circuit breaker or any other switching equipment disconnector did his job, I would definitely not breathe this air that is coming. This means that if I am using this equipment, I have to take care about the gas that is in the switchgear. So when I have to decommission it, I cannot just open it and lead it to air because there are actually compounds that are created as a result of arcing that should not be released into the atmosphere. So clean air is a good term, but I would prefer to talk in technical terms about technical air and in any way not to breathe it.
So Arturos, this technical air, it's used in vacuum technology in high voltage?
Well, it depends how high is the high voltage that you mentioned. But we can discuss it. I think vacuum technology with air insulated or with other gas also, it has been used in an established technology in what we call medium voltage. These are the voltages which are below 72 kilovolt.
Right.
There, it's a commercial existing solution. We have also commercial solutions go to the lower end of what we call real high voltage, where we are also in the industry. That is for 72 and 145 kilovolt. It's not, there are still some challenging requirements and ratings which are not fully covered by the vacuum plus air insulation technology, but it is present in the market. However, when we speak about the real high voltage, and like I referred to for 20 kilovolt earlier, because of all the parameters that we discussed earlier, size, technical performance, what Navid has mentioned, because that is the must actually, that's not to be compromised or discussed, reliability. We are rather talking about concepts and prototyping and on that level of things. So far, there is no really fully proven product, either released or type tested, where we can say that this can be used in that voltage. So I think there are lots of open questions and to be answered before we can talk about real product installations rather than theories and concepts and prototypes for high voltage, which is above 145 kilovolt.
Got it. Okay, thank you. Thank you for explaining. I think we've got time for one last question. So very quickly, I wanted to find out. So we've got Seagrey a few days away. Hitachi Energy delivered the first Econiq 420 kV dead tank breaker to a customer last year. I think it was June 23. Last month, June 24, we delivered the first Econiq GIS 420 kV to another customer. Seagrey a few days away. Is there anything you'd like to tell us? What have we got coming? I mean, you mentioned your technology is scalable. So what should we make of that?
This is a surprise. No? We
Okay.
cannot disclose it here, but I can tell you, if we talk about our Iconic portfolio and roadmap, there is no deviation.
Right.
We are on time, and I would like to invite you coming and visit us in the secret, and you will see what we are going to present.
I will come, Navid. So. Thank you for the invitation.
All right. That's it for today. Thank you so much, Navid and Arturos, for
Thank
coming
you,
in and telling
Barbara.
us all about
Thank you.
Iconic. It's been wonderful having you chat to us about the history of the portfolio and the great things to come, for telling us how reliable it is. We've proven it. It's been done now. And how scalable it is. I mean, good things to come. Stay tuned for the next couple of days, and see you soon.
Thanks
Thank
for
you.
having us, Barbara.